This is a lot easier than what it looks like it is. Because what I want you guys to think about is when you have inequalities, think back to the real basic stuff. 2x minus 1 is less than 5. What do you do? You treat it the same way like you would have been an equal sign, just solve for x. So you add 1 and divide by 2. Now, how would you graph that?
You do
The number line, right? You would graph this on a number line. This, you'd put in the middle. You agree? Now there are numbers that are bigger than 3, and there are numbers that are smaller than 3. What's a number bigger than 3?
4. Or 5.
Or 5. So, see, there are 5s out here.
Sure.
What's a really easy number to work with that's smaller than 3?
0.
0. Gotcha. But what I'm saying here is that it divides things into what are called, remember this term, half planes?
No.
Cuts it in half. One side of the values are true, the other side is false. What way are numbers smaller than 3? Left or right? So we would circle that. Did I fill that in?
No.
Why not?
Because it's not equal to.
Good. And we knew that was going this way because I was covering the truth. Remember that vaguely? Sir?
Why doesn't it have to be the same?
It doesn't have to be.
Sucks, okay.
What's that?
I'm asking why.
Why isn't it? It doesn't have to.
Yeah, we don't.
You can put any. I can put 10 and negative 50 if I want. I'm just looking at really quick, easy numbers. 5, 10, zeros, things like that. It just doesn't have to be even in space. You just pick them out. Okay. Now, when you guys did this, you were looking at it, there's one side of that number line is true. The other side of the number line was false. Okay, bueno.
I don't know what that
And then you went into this. You went to that then. After you graphed single terms, you went to double variable. They were still linear. You would graph that. But where would you start this graph? Where do you start that graph? 2x minus 1.
Negative 1.
At negative 1. And then what would you do? Up 2 over 1. Or down and left, correct? All right. When I connect those, was it a solid or a dotted line?
Dotted.
It's dotted again because it wasn't equal to. You would go through this. And then this turned the problem into 2 parts of a graph. One half the graph was true, one half the graph was false. You guys chose what was called a test point. You picked a point on one side of the graph to see whether or not it was true or false. More often than not, 99% of the time, you guys would always test it at the origin. If the graph doesn't go through the origin, you would always pick 0, 0 to see if it was true or false. So did this graph go through the origin? No. So we picked the ordered pair, 0, 0, as a test point. We would say 2 times 0 minus 1, is that smaller than 0? Is that true or false? Is negative 1 smaller than 0? Yes. That was true on this side, which means this side was false. And do you remember what direction you always shaded? You always cover the truth.
Oh, I thought you meant like what
I don't remember stating it.
No, we always shaded the truth.
I don't remember that either.
We did that. We might not have said it as We would say, was it true or false a lot of times, but we didn't really, we might not have actually wrote down true or false. What you did there is you split the graph. Any ordered pair above, or excuse me, that's in that shaded region would create a true value. Any ordered pair that's not in the shaded region would make a false statement. It goes back to the idea of that number line. Any number that's in this that's shaded, bless you, any number that I pick, 0. 2 times 0 minus 1. Yep, negative 1 is smaller than 5. If I pick negative 10, 2 times negative 10, negative 20, minus 1, negative 21. That's still smaller than 5. Any number that I pick going to the left will always be a true statement. Yes, ma'am?
So you said like 0, 0 is just like, do they both have to be like the same number? Like
You could pick whatever you want. I could have picked negative 10 and 0. I could have picked any one of those. 0, 0 is just really easy to work with. That's all. Yes, ma'am?
So the two that we did, would that be like 2 different problems or like one?
Yeah, I went from just a number line, then I went to a single variable.
Okay, because I didn't know if you like after you finish this, you would go with
No, it just,
this. It's one or the other.
right. Because now what we're going to do is we're going to look at it in terms, and you might have done a little bit of this with quadratics last year. Because
so
it's very similar to what
this
we.
is not.
Are those two different?
Yeah. Yeah. Did I pick the same numbers?
Yes.
Yeah.
Oh, that's weird. I didn't realize I did that.
You did
I mean, even if this was an 11, how's that?
yeah.
Still works the same way. You just. Just the graph moves.
I was so confused when I was like.
I didn't realize I picked the same numbers. I didn't know. I'm sorry, guys. I didn't realize I did that.
It's not okay.
You'll get over it, though, right? Hope so. Then you can go into something like this. What is it? X squared plus x. You probably did this last year when you dealt with quadratics. Very end of the quadratics, you might have did some shaded region problems with quadratics. We did. I think we did. It's possible. Now, if you go to graph this, what do you think you're doing? Just like you said earlier, you graph it the same way you would you would treat it with an equal sign. When you graph a parabola, one of the easiest ways to do that was to find the zeros and then work backwards out of that. When I factor that, I picked one that we just did a second ago. This was x plus 4, x minus 3. You agree on that? Which means my zeros were at negative 4 and 3. Is this up like a cup or down like a frown? It's up like a cup. Where's the axis of symmetry? Negative half. It's at negative half. It's the halfway point between the zeros. Negative 4 and 3 is negative 1 half, that is negative 1 half. So I know that somewhere in here is that axis of symmetry. And then I would be able to find my vertex and whatnot. But for the sake of argument, I'm just going to draw the parabola, okay? When I draw this, with this, I'm going to make it a solid line just so we don't have to worry about it. I'm just going to draw my curve, okay? I don't. I could substitute in negative 1 half and find it. But for the example, I'm just showing you what's happening via the graph, okay? Now, what this question is asking you, where is it less than y? So you still have, this graph now has basically broken this into 3 spots. You have numbers that are smaller than negative 4. You have numbers that are bigger than 3. And then you have numbers in between. Okay? What you're trying to do is pick numbers, like via ordered pairs, if you will. Where is it true and false? For example, 0, 0. That's in between here, right? If I use 0, 0. Is that true or false? True. If I pick -5, -5 and 0 for y. I get 25 minus 17, which is, thank you, is 8 smaller than 0. That's false. So it's false here. It was true in between. And might as well use +5 on the other one. I'm using the ordered pair -5, 0 and 5, 0. Is that true or false? False. So, same basic idea, but you're adding more test points. You're breaking it into different values. That's kind of what we're working on today. That's nonlinear, and how are we going to be able to come up with where things are true and false, between what ranges? That's the kind of stuff we're going to look at. It's not very difficult. It just takes a minute or two to understand what exactly is it looking like via like a number line or via a graph. Okay. So let me show you some of the stuff that they're doing in here. If I pick any ordered pair in between there, it'll be a true statement. Think of it as like a shaded region. Where is it true or false? When I had this, we were 2 parts. It was just linear. When we switch into here, with the curve like that, it has 3 sections. There's a section here, section in between, and on the other side, because of the way that it's a curve. If it was a straight line, it's just 1/2, 1/2. Okay? So these curves and stuff, depending upon what the function is, we could have multiple parts. If it's a 3rd degree, 4th degree, things like that. But it all stems from, can we factor plot zeros in test points, really? Okay. So what I want to do is kind of the same idea. I want to factor x squared minus 2x minus 3 into its terms. So what's x squared minus 2x minus 3 factor into? X minus 3, x plus 1. Which gives you zeros where? So then I'm going to line them up on a number line. So which one would go first?
Well, duh.
Oops.
Okay.
Yeah. You might not have heard, you didn't hear her say, well, duh.
Yeah, that's fine.
She's just reading right from left, that's it. Okay. Now, so these are your zeros. Your 0 is at -1. You have a 0 at 3, which means you have a test interval. You can pick any number that is smaller than -1. Now, that means I can pick any number that's smaller than -1. Well, how can I write that in terms of an interval? Remember intervals?
No. What is what? No.
Negative infinity to -1.
And then the other one is
Between these guys would be between -1 and 3. And then this one would be anything between 3 to positive infinity. I get going out this way. Here's the in between. So it breaks into 3 parts. these test intervals are what we're going to be coming up with. And the way we get those is the same way. We're going to factor and plot zeros. And you're going to break yourself into your intervals. And that way you can tell whether or not things are true or false. That's really all there is to this. Okay. So let's look at an example. Let's solve this one.
Okay, so we're not doing any more on that.
No, and I'm just showing you where, like, we've been progressively getting to where we're at now. If I have x squared minus x minus 6 less than 0, and I want to solve this inequality for where this polynomial is smaller than 0, we're going to look at our intervals to figure that out. So, first thing we do, factor. What times what's negative 6? You add together, you get negative 1. Negative 3, positive 2. We okay with that? Okay. So we have x minus 3, x plus 2. So my zeros are at 3 and negative 2. What goes first on the number line?
Negative 2.
So think about your intervals. I can pick any number that's smaller than negative 2, any number that's between negative 2 and negative 3, and then any number that's greater than 3. I want you guys to get in the habit of picking really easy numbers, like 0. Is 0 between those two?
Yeah. So.
I'm going to use the test point at 0. Maybe, I don't know, negative 5. It's a pretty easy number to work with. What do you think I'm going to use on the other side then? 5.
Whoa.
Okay, because these are my zeros. So when I go back and I start substituting in, well, 0 squared minus 0 minus 6, I get negative 6. Is negative 6 less than 0?
Yeah.
So it's true between. Okay? Use negative 5. Negative 5. Make sure you have it in parentheses if you're using your calculator and you're squaring that. Minus a negative 5. Minus a 6. 25 plus, 25 plus 5 minus 6? That is 24, which is not less than 0.
Wait, do they always, like, is the second number always zero, or could you pick, like, negative 5 and, like,
Yeah. I'm trying to get you
pick 0 because it's easiest?
Yes. Yes. I could have chosen 1.
Different if, like,
No. If you use 2. 2 is between negative 2 and 3, right?
No, but like if I did like negative 5, so there's like negative 5 comma 3, can you do that?
Ah, I see what you're saying. You're thinking more along the lines if we're graphing them, graphing them.
Yeah.
Look at ordered pair. I wouldn't worry about that because I want to do this via the number line for right now. Okay, but you'd have to know which way the curve's going. This alleviates having to worry about the curve.
Okay.
Okay. So this is false. And then I'm going to use 5 again over here. So I get 25 minus 11, which is not smaller than 0, so it's false here. So basically what this tells me then is that any number between negative 2 and 3 works. Okay? Any number between 2 and 3. So the answer, I believe you want to write them as a solution set, would just be between negative 2 and 3. Oops. That's what it would look like. Do you remember the difference between the soft bracket and the hard bracket?
Yeah.
What did the hard bracket stand for?
It included it.
Included versus excluded. I forgot what that word was. Including is the hard bracket. Excuse me. If this was, if this was a less than or equal to, because I want to include the 0, it would have been a hard bracket. Does that make sense? You guys remember that?
Yeah.
That's all that means.
They both live in high
It depends on. It really kind of depends.
So if it's less than or equal to. So if it's like 64, you do that.
It's a hard
At least I
graph.
think that's your
Let's try another one.
Oh my, now the numbers in front of them.
Okay? Let's look at it in terms of a cubic.
Oh man, what is this? This is a lot of work.
2x cubed minus 3x squared minus 32x is greater than negative 48. Like Izzy was saying earlier, a lot of these things you're going to treat it just like you would an equal sign, which means I got to factor and find zeros, which means you have to have a side equal to 0. What do I do with the negative 48? Add it over. Good. So we add it over. We get 2x cubed minus 3x squared minus 32x plus 48. Four terms, third degree polynomial. First thing you always want to try and do is factor it via grouping. Okay? So if I do this via grouping, what's the GCF there? They both have 16 in common? They both have a 16 in common. Factor out this negative 16, we have, dun dun dun, 2x minus 3. Could you go through and use synthetic division all day long to find all the zeros?
Yeah.
Absolutely. So you have x squared minus 16 and 2x minus 3. Where are your zeros? Plus minus 4, good. And then 3 halves. All right. Put them on a number line. What's the order in which they would go on the number line? Sounds so excited here. So we have negative 4, 3 halves, and 4. Which means we're going to have how many spots to test?
4, 5.
1 little, 2 little, 3 little spots. 4.
It should have been like 4 little spots.
So you have testing spots to check now. Okay? It's totally up to you which values you use. Okay? It's going to be completely up to you. If you use, negative 5. What's between negative 4 and 1/2? 0. What's between 1.5 and 4? 2. And maybe use 5. Okay? And we're going to find true and false. Okay? For sake of time, negative 5. 0. 2. 5.
Yes. I want to. No, you don't get to. We get 5.
You guys got 0. Good luck with that.
What?
You're testing at 0.
Oh, it was split down by rows? How fancy.
I just want 0.
I was not.
Dude, I can't do it.
Obviously.
My hands are right at 2x. Jack. You might have to go to a chiropractor.
He's used to it. Ball 250.
Five cubed times 2 is 2
Maybe not. I don't know which
So far.
There's only like 7 minutes in the What'd you guys get? 125 times 2, double 125.
Is it greater than 0?
It's not.
That's.
It's,
Is it true or false with 0?
True.
wait, 15 is greater than.
Is it true or false with 2?
It's true.
So one said false. False, and you're saying true.
Trent added it right.
False?
True.
Is Is it true or false with 5?
It's true.
We had worked.
Yeah.
You had negative
I
5.
trust the
And
man.
never mind.
All right, it's false. Okay. So what happens now is that I've got 2 of these sections work out that they're going to be true. So I have 2 intervals of truthfulness. I have truthfulness between -4 and 3/2. And then I have it between 4, and then what do I write to the other side? Positive infinity. The hyperbolic paraboloid.
So do it like
So-
and or
And that would be your solution set. If it changed, if let's say this was a less than or equal to, or sorry, greater than or equal to, then it would, these are hard values here. These would then be hard brackets. Do you put a hard bracket on infinity?
No.
No, very good. Because you're never really getting there, so it allows you to continue, all right? That's why you don't have a hard bracket on infinity. That's, just wanted to show you the difference between those two. Okay?
He's like, but wait, it gets harder.
No, we'll do the rational stuff tomorrow. Just real quick here, there are times that you may or may not get anything to work. You could have all real numbers. You could have only 1 point. You could have an empty set. You could have what is it? Everything except for 1 value. It always depends on what it's asking you to do. You guys, once you break it down into all your test points, you'll come across where you might have false across everything. That just meant that maybe the curve never crossed the axis. Okay, it could be all real depending upon what it was written out as. Yes, ma'am.
Are we only doing the number lines?
Yeah, we're gonna worry about. We'll do more. I think most of it's all number line stuff. I don't think I give you anything with the rational stuff. We'll look at more of that tomorrow. It's pretty easy to work with. You kind of do the same idea, but I just wanted to show you that in the book it does a really nice way of explaining what it means by not having or all real numbers or just 1 value because it just touched the axis in 1 spot. Things like that. Okay. Just pay attention to your signs. If it's a greater than or equal to, less than or less than or equal to, that way you know what to look for. The homework stuff then, what was it? 9 through 21, every other odd, and then 37. You know what? Why don't we do this? Because we didn't do any of the rational stuff. Let's do this. We haven't done any of the rational stuff yet, so as far as the homework stuff is, why don't we just make it the 9 through 23 odds, okay? The 9 through 23 odds, because we haven't done any of the rational stuff yet.
Do you want us to go 23 or 21? It says 21.
What is it?
Mine says 21.
Right, but then if you look at day 2 says 11 through 23, every other odd also. So what I'm saying here is let's just do this. For today, let's just do these, which is basically 9 through 23 odds. Okay? We'll talk about the rational stuff tomorrow. It's not
Just
that much more different. It can be a little bit weird, that's all. That's why I didn't want to. Yeah.
Every other odd?
No,
we didn't ask.
Odds.
Odds.
Evens.
Hey guys, if you do 9 through 21 every other odd, it's skipping
Still all
11
odds.
through 23 every other odd. So that's why I'm just saying, put them together and you do all of them. Whoa.
Yeah, I guess, but I still think that we should do
Hey.
every other.
I thought something.
Would you like to do my?
Maddie, how about this? You do every other odd on 9 through 21, then when you get done with that, do every other odd between 11 and 23.
Tomorrow.
No, it's for tomorrow. Do both of those tonight, okay?
You got both today.
We're gonna do the rational stuff. I don't know what's so difficult about, you were on your phone the whole time, so it doesn't matter, I shouldn't even be talking to you. So, it's,
maybe that's
but I've been talking about it, I don't understand.
Oh, 10 squared. Just call you say.
It's actually Thursday.
Yeah, and.
Like,
Yeah, test is Thursday.
I just kinda like.